start the video off with how quercetin can help brown fat in the context of magnesium. Now, magnesium is important in brown fat because of the TRPV1 receptor. I'll explain here first. With quercetin, quercetin chelates zinc. Basically, it prevents zinc from inhibiting cathepsins, which disrupts lysosomal membranes because this suppresses magnesium-dependent enzymes that helps repair the lysosome and membrane peroxidation. Because if the membrane is leaking, because magnesium cannot repair it, then iron leaks, the cathepsins leak, causing apoptosis, meaning a reduced T cell count and cancer cell interactions, because the T cells can undergo apoptosis as a result of iron and cathepsins leaking. That is why magnesium is needed to repair the lysosomal membrane under peroxidation. With zinc being reduced by quercetin, this reduces testosterone, because high testosterone reduces estrogen, and estrogen is needed for the magnesium transporter, because the magnesium cannot work without the magnesium transporter. Because when zinc is excessive, testosterone is too high. This is where magnesium is important in brown fat, because in brown fat, the TRPV1 is activated. It is a receptor. When it's overactivated, and this happens when magnesium is absent or deficient, which is why you can't lower your estrogen too much, is that the TRPV1 receptor in brown fat causes a calcium flood. Also, reactive oxygen species surge and immune cell apoptosis. This can be prevented with magnesium. Now, the reason brown fat is important, it can help in a cancer metastasis situation, because brown fat can hog or steal glucose, amino acids, and substrates away from cancer cells. So brown fat starves cancer cells. Brown fat can be problematic if magnesium is missing or deficient. That's why it's important to avoid excessive zinc, which will raise testosterone. Testosterone lowers estrogen, therefore lowering the magnesium transporter. Magnesium paired with brown fat is a controlled thermogenesis, so buffers calcium influx after TRPV1 activation, prevents mitochondrial permeability, also prevents excessive reactive oxygen species, also preserves insulin sensitivity, which is another word for the opposite of diabetes. Insulin sensitivity is basically when the cells are very sensitive and they can easily uptake nutrients. It's beyond the scope of this video. This video is mostly going to be about brown fat. So in brown fat, TRPV1 is not the problem. The problem is unbuffered TRPV1 because of no magnesium. What happens when magnesium is too low and the zinc is too high? The TRPV1 in brown fat is a chronic calcium stress, lipid peroxidation, lysosomal leakage, and immune suppression. When the lysosome is leaking, it's because magnesium isn't there to repair the lysosomal membrane. Therefore, the iron and cathepsins leak. A good way to boost up brown fat is with conjugated linoleic acid from beef. Also, it's in dairy. It activates PPAR alpha, which increases expression of genes involved in fat burning mitochondria, which will increase energy expenditure and reduce fat accumulation in certain tissues. CLA in meat will increase mitochondrial biogenesis, BAT, or short for brown fat. CLA in beef also modulates excessive brown fat activity, preventing overactivation of excessive brown fat. Because if brown fat is excessive, it can actually hog too much arginine or some other substrate. Excessive brown fat can be problematic. That's why beef helps balance out brown fat as compared to other compounds like green tea or ginger. Maybe green tea and ginger can boost brown fat, but it can't modulate it the same way that beef can. And it's a CLA in beef. Brown fat can have a positive effect on the immune system because brown fat upregulates PGC1A. What that does is that it boosts mitochondrial longevity and numbers. immune cells need they're a high energy demanding cell. Brown fat also upregulates NAD, which sustains SIRT1. Brown fat also helps with a phagocytosis and antigen presentation. Antigen presentation is where the antigen presenting cells, they help the T cells see, or the antigen presenting cells, they train the T cells because the T cells need their help. The antigen presenting cells, they're like the drill sergeant of the boot, and the soldiers are the trainees. The soldiers would be the T cells. Brown fat helps with that. Another thing that can activate brown fat is a capsaicin in a chili. Increases nitric oxide. Capsaicin activates TRPV1 channels, macrophages, and the sensory neurons. This also promotes phagocytic cup formation. Capsaicin also helps in combination with increasing brown fat directly. Is that capsaicin also improves the calreticulin exposed on the cancer cell, then the CD91 on the T cell or the immune cell. So the immune cell has the CD91, the calreticulin is exposed on the cancer cell, which is what the T cell needs. The T cell needs to see the calreticulin to attack the cancer cell, which is why the immune cell needs the antigen presenting cells to train them and teach them. Brown fat, two things at the same time. It helps the CRT CD91 axis, or the CRT on the cancer cell and the CD91 on the immune cell. Brown fat also hogs glucose and amino acids and other substrates away from cancer cells and tumor cells, because that's what they need to survive. Cancer cells and tumor cells need glucose and fats and amino acids to live. It's pretty much a lethal combination that brown fat can have on cancer, on the battle against cancer, only if a brown fat is correctly and safely by managing the magnesium, because the low magnesium will cause the TRPV1 receptors to become excessively calcium in efflux stressful. Another good one to add in to help brown fat, it's one of my favorites, is flaxseed meal. There are these flaxseed crackers, that cheese flavored, that you can find at in Aldi. Basically, flaxseed helps produce short chain fatty acids. Flaxseed increases AMPK, which generates ATP. That means that flaxseed is good for your mitochondria. So flaxseed boosts mitochondria. As a result of that, your immune cells get the ATP they need to fight cancer. AMPK also stimulates PGC1A. PGC1A is a master regulator of mitochondrial biogenesis. That flaxseed boosting PGC1A also means more mitochondria in the brown fat. Recap: quercetin reduces zinc. Their high testosterone is not lowering estrogen. Is able to boost the magnesium transporter. Magnesium is important in brown fat. Without magnesium, excessive PV1 activation in brown fat can lead to calcium stress. Brown fat being activated effectively takes substrates such as glucose and amino acids away from cancer cells, starving the cancer cells. Capsaicin helps the CRT CD91 act where the immune cell is able to attack the cancer. Flaxseeds boost PGC1 to boost mitochondrial numbers and strength for the immune cells. Leave your comments down below about your own insight. Comment, subscribe, share, and I'll see you in the next video.